Hello everyone, today I am going to explain asymptotic notations which are used in algorithm analysis to measure the performance of algorithms. Algorithm analysis is the process of studying how an algorithm works. It, it helps us to understand how much time, space, and sometimes power an algorithm requires to solve a problem. Here we use frequency count method to calculate time complexity. Each statement in the algorithm is counted based on how many times it executes. For the given sum algorithm, the total function becomes 2n plus 3, and hence the time complexity is big O of n. Asymptotic notations are mathematical tools used to describe the performance of algorithms when the input size become very large. Why asymptotic notations? They help us compare algorithms without depending on hardware or programming language. We use asymptotic notations to predict scalability, focus on dominant terms, and analyze algorithms efficiently instead of measuring exact execution time. There are three main types of asymptotic notations: big O, omega, and theta. Coming to big O notation, big O notation represents the upper bound of an algorithm. It gives the worst case time complexity, meaning the maximum time an algorithm may take. Consider the f of n as the time complexity of an algorithm, and g of n is the most significant term. The function f of n less than or equal to constant into g of n for n greater than n naught, c greater than 0, and n not greater than or equal to 1. Then we can represent f of n as big O of g of n. Then we simply write f of n equal to big O of g of n. The graph represents the visualization of big O notation. In the example, f of n is 3n plus 2 and dominant term is g of n equal to n. Coming to solution, if you want to represent f of n as big O of g of n, then it must satisfy f of n is less than or equal to constant into g of n, and c greater than 0, n not greater than or equal to 1. Coming to equation, f of n less than or equal to constant into g of n. F of n is 3n plus 2. G of n is n. Above condition is always true for all values of c equal to 4 and n equal to 2. Then solve this equation. We will get to 3n plus 2 equal to big O of n. Constants and lower order terms are ignored, so the time complexity is big O of n. Next type of an asymptotic notation is omega. Omega notation represents the lower bound of an algorithm. It indicates the best case time complexity, which is the minimum time required. Consider the function f of n as time complexity of an algorithm, and g of n is the most significant term, and the function f of n greater than or equal to constant into g of n, where n greater than or equal to n naught, c greater than 0, and n naught greater than or equal to 1. Then we represent f of n as omega of g of n. Then we see the visualization of omega. F of n is greater than or equal to g of n. Example of omega notation: f of n equal to 20n square plus 2n plus 5. Dominant term g of n equal to n. Coming to solution, if you want to represent f of n as omega of g of n, then it must satisfy f of n greater than or equal to C into G of n for all values of C greater than 0 and n not greater than or equal to 1. Coming to the solution, the above condition is true for all values of C equal to 20 and n greater than or equal to 1. Then the best case time complexity is omega of n square. Coming to third type of an asymptotic notation, that is theta notation, represents the average bound of an algorithm, and it shows the both upper bound and lower bounds and gives the average case time complexity. Consider the function f of n as the time complexity of an algorithm and g of n is most significant term. If c of n into g of n less than or equal to f of n less than or equal to c to g of n, the function shows f of n equal to theta of g of n. The graph represents the visualization of omega of g of n. C1 into g of n is less than or equal to f of n and greater than or equal to C2 into g of n. Theta notation represents. Example of theta notation, f of n equal to 2 power n plus n square. The dominant term g of n is 2 power n. Coming to the solution, c of n into g of n less than or equal to 2 power n plus n square less than or equal to c2 into g of n. Then we can solve the above equation. We will get 2 power n plus n square greater than or equal to c into n. The above condition is always true for all values c1 equal to 2, c2 equal to 1 and n greater than or equal to 1. Hence, we get the time complexity is big O of 2 power n. This is the example of asymptotic notation. Given an array of n integers and key element is x, determine whether x is present in array. If found, return its index, otherwise return -1 if element is not found. Coming to time complexity differences, worst case time complexity is big O of n when the element is not found. The best case time complexity is omega of 1 when the element is found at the first position. Average case time complexity is theta of n. Thus, asymptotic notations help us analyze and compare algorithms efficiently by focusing on their growth rate. Thank you.